Okay, so question 14. We're looking at a case of free body diagram in the context of electric forces question. So we're given an electric field between the plates of a parallel plate capacitor. It's uniform and it's horizontal, in this case pointing from left to right, from the positive plate to the negative plate. It has a magnitude of 1.46 by 10 to the 4 newtons per coulomb. There's a small object of mass 0.5 kgs and charge negative q is suspended by a thread between the plates. Shown in the sketch, the thread makes an angle of 15 degrees with the vertical. Find the magnitude of the charge q. Yeah, it's very similar to the mechanics question. So I'll start with thinking about the free body diagram for the object. So I know it has a weight force that points downward. So the weight force on the object by the Earth. If a negatively charged ball, or object, is being attracted to the positive plate and repelled from the negative plate, and negative charges always experience forces opposite the direction of the electric field. I'll try to do this somewhat accurately. So this is going to be the force that is on the object by the electric field. And then there's a tension force now. And I'm probably going to try to draw this reasonably accurately. I'm sort of giving away the answer here. I'm drawing my force diagram. So I've sort of purposely made the y component of the tension equal to the weight, the x component of the tension equal to the electric force, and I haven't done this completely accurate to the diagram, but I'll explain in a second. And this is the tension force that's on the object with the string. Okay, so the object is at rest, and so if we know that the sum of the forces must be 0. So I'll break up this tension force. It's the only one that's sort of awkward, that has both an x and y component. So there's a y pointing upwards and a x component pointing to the right. From the diagram, this is the angle here, theta. So from this particular diagram, what I can tell is that the magnitude-wise Tx equals FOE, and this is the tension x component, and then the tension y component is equal to the weight, which is equal to m times g. We're trying to solve for the q, and the q is linked here in this electric force, which is q times e, in these for magnitude. So I'm just looking, these are all only magnitudes. These vectors pointing, the Tx and the FOE point in different directions, so I'm just doing magnitudes here. So the q is in here. I do have the size of the electric force, I have the mass of the object, so I somewhat want to kind of connect the Tx to Ty, and I can do that through trig. So I can see that the tan of theta is equal to the opposite, which is going to be the Tx over its adjacent side to that angle. But we just said that Tx is equivalent to q times e. Ty is equal to the weight, which is equal to m times g. So now I can think about connecting q here. So q is going to be equal to tan of theta times m times g, all divided by e. And we have all of these quantities. So that's a tan of 15 degrees. The mass is 0.025 kgs, 9.8 meters per second squared for g, all divided by the field strength, 1.46 by 10 to the 4 newtons per coulomb, and that should give you a Q of 4.5 by 10 to the minus 6. So 4.5 microcoulombs. So choose choice A. So yeah, question sort of focuses on free body diagrams going all the way back to a mechanics course, thinking about force on the object, thinking about component vectors of forces, and then some algebra.